Welcome. In this video, I will show you how to solve the integral from 0 to infinity of the square root of the natural log of a over r dr. Okay, here a is just any constant. And well, how do we solve this? Well, the problem in this integral, right, you always have to think, what is the thing that is making this integral hard for me to solve? We know how to solve the integral of, for example, the square root of x or something like that. So it would be natural to try to think, okay, maybe the problem comes from this natural log. So let's use substitution. So say z is equal to the natural log of a over r, and let's see if this takes us anywhere. So if we do this, we could solve for dr, for example. To do that, we need to exponentiate both sides here. So we get e to the z is equal to, here the natural log will cancel out with the exponent function. So we get a over r. So from here we can find r, right? We multiply by r, we divide by e to the z. So we get r is equal to a times e to the minus z. And here we can differentiate and we find dr, which will be minus a e to the minus z dz. So here we can find dr. So let's plug it in. Now, what about the limits of integration? Well, if r is 0, we can see it easiest here. If r is 0, then z has to go to infinity in order for this exponent to also go to 0. So the lower limit is now infinity. What about now when r goes to infinity? Well, in that case, we need z to go to minus infinity in order for this expression to also go to infinity. So our integral then goes from infinity all the way to minus infinity. Okay, and then we have the square root of z, right, plugging in the expression for the natural log. And then we have the expression for dr, which is minus a e to the minus z dz. Now, minus a, of course, we can simply take out of the integral, right? That's simply constants. So we are left with the following integral. So we have integral, and let me write it like this. So z to the 1/2 e to the minus z dz. One thing that I will do now is I will use this minus sign to flip our limits of integration, right? So I will use this minus sign, and now it goes from minus infinity to infinity. Okay, and I will just write it down a little bit more compactly. So this is e to the minus z dz. So what we have to solve now is this integral. How can we solve it? Well, fortunately, we don't really have to do too much because this is the gamma function. So the gamma function of some variable t is defined as the integral over all of the possible values of t, so minus infinity to infinity, of x to the t minus 1 e to the minus x dx. And if we compare our two expressions, then we can see that if we have t equal to 3/2, then we have 3/2 minus 1, which is exactly 1/2. So what we have up here is exactly gamma function evaluated at 3/2 and of course multiplied by a, so times a. And what is the gamma function of 3/2? Well, the gamma function has quite a few properties that we can use. So first of all, if we have x times the gamma function of x, then this is the gamma function of x plus 1. So if we have the gamma function of 3/2, we can write it as gamma function of 1/2 plus 1, and thus, right, x would be 1/2. So that means that it is the exact same as the gamma function of 1/2 times 1/2, right? This is a recursive relationship. The gamma function is this extension of the concept of the factorial. So that's why we have these properties that are kind of similar. And what is the gamma function of 1/2? Well, the gamma function of 1/2 is the square root of pi. So that means, right, this thing is the gamma function of 3/2. And as we have seen, it is 1/2 times the square root of pi. So plugging that back into our integral here, then we see that our result is simply a times the square root of pi divided by 2. And there we go, that is the integral. As you can see, it is quite simple. What we were looking for is to try to bring our expression into the form of a gamma function. And integrals that are of this form, of the square root of something, they lead you sometimes to the gamma function. So it's very important that you can at least recognize whenever you have an integral that looks something like this, because the gamma function can help you and save you a lot of trouble. So I hope that this video was useful to you. If it was, please make sure to leave a like on the video, comment and subscribe, and maybe even consider checking out my Patreon. I'll see you in the next video. Thank you very much for watching.